we're going to look at measures of center and spread. Now, if you remember your junior year level stuff, you would look at mean, median, and mode usually. So remember, if you have the mean, that's usually about the halfway point or the average. If you're looking at spread, you would then look at variance or standard deviation, which tells you how far apart the data is. So we'll start with the mean, the expected value of the mean. All of this is essentially saying you multiply your value by the probability and then just add it all up together, and that'll be your expected value. So find the expected value of the random variable with the following probability distribution. So sometimes you'll be expected to do this by hand, sometimes, or most of the time, you will just be expected to do this with a calculator, but you need to know both, so it's better if I do it by hand and show you. But I will say, normally if you do it by hand, you'll have much simpler probabilities in this. I usually don't mind so much. If you've had me in class, you'll see that I work it out pretty fast anyway. 6.8 plus 3, so 4.8 plus 4, so 3.8 plus 0.5, I think. Yep. Then add it all up together. So then you have 11 plus 7, 6, 0.5. So that'll be 19.1. Alright, so expected values follows a kind of linear transformation trend. If you don't get what I mean, you'll see it later. All it really means is there are certain rules you can put onto it. So you can multiply it and also add stuff to it, and then it will just be multiplied and added. Now, important one for you to know, and this will pop up when we do variance, x squared is different to ex all squared. We'll cover that a little bit later. A discrete random variable x has the following probability distributions. So if f of x is equal to 1, find the value of the constant d. Now you can see I've pulled my CAS up just to make it easier for ourselves. So we have, remember you multiply and you add everything, so that's 5 minus d times 7 over 20 plus 3 minus d times 9 over 20 plus negative d times 1 over 10 plus 3 plus d times 1 over 10, and we want to solve. So if you don't remember how to get to solve, action, advance, solve, and we want to tell it to solve for d. Right. Sorry, made a mistake. I need to write equals to 1. Otherwise it will solve it for equals to 0. So d is equal to 3. So what is this? Part A. Insert equation. D equals 3. Alright. So B, we want E of 7x. So we have E of 7x is equal to 7 times E of x. Because E of x is 1, that's a 7 times 1, which is 7. 2. E of 5x plus 3, so that'll be 5ex plus 3, which is then 8. And the last one, E of 3x minus 2 is the same as 3ex minus 2, of these measure spread. Standard deviation technically measures it based on the original values terms, whereas variance you square it, which means in terms of what you're doing mathematically, it's more important. Anyway, the main things you need to know is variance is sigma squared, which is then what I was mentioning, e bracket x squared minus ex all squared. So to do that, you need to understand difference. I believe this is written incorrectly, by the way. I think that's actually e of x all squared like that. Anyway, the difference between it is this one, you square all this x's first, then you sum it up. Then you multiply the probabilities, then sum. So then you add them all up. This one, you just find e of x, then you just square it. And then standard deviation, you square root the variance of x. Alright, a discrete random variable x has the following probability distributions. So A, find e of x. So add them all up. 1 times 0.15 plus 2 times 0.25 plus 3 times 0.3 plus 4 times 0.2 plus 5 times 0.1. So then you get 0.15, 0.5, 0.9, 0.8 plus 0.5. So that's 1.9, 2.7, so 2.85. Let's double check. Yep, sounds good. And then B, variance. So then we have e of x squared minus, not plus, e of x whole squared. Now normally you'd be expected to probably do this by calculator, unless they literally tell you to do it by hand, which usually won't happen. Anyway, so let's see how that first one works. So it's 1 squared times 0.15 plus 2 squared times 0.25 plus 3 squared times 0.3 plus 4 squared times 0.2 plus 5 squared times 0.1, then we subtract what we found earlier, 2.85 squared. So at this one I'm going to cheat and use a calculator because I think that's ridiculous to work out by hand. In a calculator it will give you 1.4275. C, standard deviation, you just simply square root that, and that'll give you 1.1948. Alright, so variance also has some linear properties, but you might notice that doesn't do anything because you have to remember we're doing spread of data. If you shift data left and right, it doesn't change the spread. It doesn't change how far apart it goes because you're moving the whole set of data together. Alright, discrete probability function is defined by the rule py equals to 1 over 12 times bracket 10 minus 3y, where y is for 1, 2, and 3. So 8. Show that the sum of the probabilities is equal to 1. So just for simplicity, I'm going to actually find each and every single one using a table. And that's for 1, 2, and 3. So if I sub in a 1, we get 1, so that's 1 over 12. We sub in a 2, that's 10 minus 6, which is in 4. So 4 over 12 is in 1 over 3. Then if we sub in a 3, oh, what am I doing? That's wrong. First one, I sub in a 1, 10 minus 3 is 7, so that's 7 over 12, that's better. And then when I sub in a 3, which is the one I was thinking of, is 1 over 12. And then show that the sum of probabilities is equal to 1, 7 over 12 1 over 3 plus 1 over 12 is 7 plus 4 plus 1 over 12, which is then 12 over 12, which is then 1. B, find E of y. So remember, multiply them. 1 times 7 over 12 plus 2 times 1/3 plus 3 times 1 over 12, and gives you 7 over 12 plus 2/3 plus 1/4, which is then 7 plus 8 plus 3, which is 18 over 12, which is then 3 over 2, so 1.5. Alright, B part 2, find the variance. So E of x squared minus EX whole squared gives us 7 over 12 plus 4 over 3 plus 9 over 12, or in other words, 3 over 4, minus E of x whole squared, so that was 3 over 2 squared. So then we have, let's put everything under 12 now. What am I doing? 7 plus 16 plus 9 minus, so that's 9 over 4, which is then 27. 16 plus 9 is 25, so 32 minus 27 gives us 5. 5 over 12. Alright, C. Find the variance of 3y minus 1. So if you look up above, it's a squared, so that's 3 squared variance of y. So that's 9 times 5 over 12, which is then 4, so 15 over 12. And then 2, variance of 4 minus 5y, so that's negative 5, but it's squared. Variance of y. Now you should always get a positive value for variance because you're squaring. So 25 times 5 over 12, which gives you 125 over 12.